Now next topic is axiomatic definition of probability. Let S be the sample space of a random experiment. The probability P is a real valued function whose domain is the power set of S and range is the interval close interval 0 to 1 satisfying the following axioms. See here, probability is considered as a function. P is a function whose domain is, here I am putting domain. Domain is power set of sample space. So domain is power set of sample space S. This is domain and this is domain, and range is close interval 0 to 1. This is range. Now see, any function can works on element of its domain. Now power set of S, it means subsets of S. Power set of S means here this is set of subsets of S. And set of subsets of S, we know that subset of S is event. So this is set of events. Set of events associated with random experiment whose sample space is S. So domain is set of events. Now if E is any event, that means E belongs to domain. So this function can work on event. So probability is a function which works on event. So we speak this as probability of E, and its value will be always in this interval 0 to 1. That means probability of any event is a value always positive. It belongs to close interval 0 to 1, that means always a non-negative. Non-negative as well as less than 1. Probability of any event cannot be more than 1, cannot be less than 0. It must be between 0 to 1. Now, so that is the meaning of this words, that S be the sample space of a random experiment. The probability P is a real valued function whose domain is power set of S. Power set of S means set of subsets of S. That means set of events. And range is interval 0 to 1, satisfying following axioms. Now coming on axioms. For any event E, probability of E is always more than or equal to 0. It is clear here. Probability of any event is always non-negative. Not only non-negative, we can here edit this statement as probability of any event is value between 0 and 1. Probability of S, probability of sample space is always 1. Sure event, probability of sure event is 1. If E and F are mutually exclusive events, that means their intersection is null set, then probability of E or F, probability of E or F is probability of E plus probability of F. Probability of impossible event is 0. So this is axiomatic definition of probability. Now, from axiomatic definition, there are some conclusions. If sample space contains n elements and probability of this event, say this is event containing only one sample point, event containing only one sample point. So probability of this event, if event contains only one sample point, simply we denote it by probability of Wi, short notation. So considering this notation, here there are statements that probability of any sample point is always value between 0 and 1. So this is clear from this definition. Probability of any event containing one sample point is always between 0 and 1. Probability of sum of all sample points which are in S. S contains n sample points. So sum of probability of all n sample points is 1. So this is clear from this statement. So keep remember, probability sum of, this is sum, left hand side it is sum of probabilities of each sample point or events containing only one sample point. See, these are events containing only one sample point. We can say elementary events. So its sum is 1. For any event A, if event A contains R outcomes, event A contains R outcomes, then probability of that event A is sum of probabilities of these R sample points or R outcomes. So probability of A is sum of probabilities of R outcomes. Sigma P of Wi, I is 1 to R. So this was about axiomatic definition. Now to understand this, there is a question: which of the following cannot be valid assignment of probabilities for outcomes of sample space as these are sample points, there are 7 sample points. Now for this sample space, from the following, which cannot be valid assignment of probabilities? There are 3 assignments, A, B and C. So meaning of this table is that in this first assignment, probability of W1 is 0.1, probability of W2 is 0.01, probability of W3 is 0.05, like this. So this is first assignment. Let me put these values in table. Let us discuss for this assignment A. For assignment A, look here. We shall apply this first two statements to check whether given assignment is valid assignment or not. These are important main properties to check whether given is valid or not. See, probability of each Wi must be between 0 and 1. Now look the first line. Probability of each Wi is between 0 and 1. No one must be negative. Neither negative nor more than 1 allowed. So for each Wi, for each first condition, for each Wi, probability of Wi is between 0 and 1. So first condition is satisfied. Second condition, sum of all must be 1, and second condition, sum of all values sigma p of Wi I127. Say sum of these numbers 0.1 plus 0.01 plus 0.05 plus 0.03 plus 0.01, 0.2 plus 0.6. Check this sum. 0.1 plus 0.6, 0.7 plus 0.2, 0.9, 0.9, 0.91, 94, 99, 1 point, total is 0.99 plus 0.01, that is 1. So here sum is 1. Sum of all these numbers is 1 and every value is belonging to close interval 0 to 1. So both conditions are satisfied. So both conditions are satisfied. Therefore, assignment A is a valid assignment. Now we discuss for B. Check here B. Say every value is between 0 and 1. For all probability of Wi is between 0 and 1. So it is clear. Now check sum. Sigma PWI I127 0.1 plus 0.2 plus 0.3 plus 0.4 plus 0.5 plus 0.6 plus 0.7. See 1 plus 2 3 plus 3 6 plus 4 10 plus 5 1.5 2.1 2.8. This total is 2.8. This is not equal to 1. Sum of all probabilities must be 1. This is not equal to 1. So second condition is not satisfied. Therefore, second condition is not satisfied. So B is not a valid assignment, therefore B is not a valid assignment. Now let us check C. Say here, this is negative, not allowed. So this is not valid assignment. So here, probability of W1 and probability of W5 are negative. According to condition, all values must be non-negative as well as less than 1. So if you find any number which is negative or more than 1, then not allowed. So here first condition is broken. Therefore here C is not a valid assignment, a valid probability assignment. So that is the application of axiomatic definition of probability. Now next is probability of event. If a probability of each sample event Wi of a sample space containing n outcomes is same, that is probability of each outcome Wi is P, same for all outcome Wi belonging to sample space. Then as we know that sum of all outcomes belonging to sample space is 1, putting this value P, so sum of all values P n times, that means P probability of this event plus probability of this event plus probability of this event, that is each one has probability P, so P plus P plus P plus P, that is n times P is 1, then value of P is 1 by n. It means probability of sample event or each outcome is 1 by n if S contains n elements. If this set contains 20 elements, then probability of each outcome is 1 by 20. So in this case, if this happens, each outcome is of probability 1 upon n, where n is number of total outcomes, then we say that all outcomes are equally likely. All outcomes with equal probability, that is equally likely. So that is the meaning of equally likely outcomes. If S contains 100 elements, then each outcome will have probability 1 upon 100. So in that case, each outcome are equally likely. Now, practical definition of probability: let S be the sample space containing n outcomes and E be any event containing r outcomes. If each outcome is equally likely, then probability of event E is r upon n, means number of outcomes in E upon number of outcomes in sample space. So maximum sums in this chapter are based on this definition, practical definition. number of outcomes in event upon number of outcomes in sample space. That is probability of that event. Then there are some results. For events A and B, probability of A union B or probability of event A or B, it is equal to probability of A plus probability of B minus probability of A intersection B. Probability of not A, event not A means A dash, is 1 minus probability of A. Probability of A intersection B dash means probability of event A and not B. It is probability of A minus probability of A intersection B. Probability of event A dash intersection B means not A and B or B and not A. That is probability of B minus probability of A intersection B. Probability of event A dash intersection B dash, that means event neither A nor B, no any event occurs. So its probability can be found by De Morgan's law. A dash intersection B dash expressed as A union B whole dash, and here this is like P of x dash is 1 minus P of x. P of x dash is 1 minus P of x. So using this result, now we are solving problems. And when solving problems, see, there are a few words, few symbols which will be given in question. As for example, event A, at least one event occurs, at least one event occurs from events A and B, at least one event occur, it is denoted as A union B. Both events occur, it is denoted as A intersection B. Whenever at least word is given, at least one event occur, take A union B, that means A union B occurs. Here A intersection B occurs. No any event occurs, neither of the events occur. That is, neither A occurs nor B occurs. So these are some symbols which already we used in set operations. Same symbol, same words we are using in case of probability. Now questions. A coin is tossed twice. What is the probability that at least one tail occurs? So here sample space associated with experiment of tossing a coin twice. So sample space is HH, HT, TH and TT. So here sample space contains 4 elements. Now event of getting at least one tail. So let E be the event or A be the event. Event of getting at least one tail. So event A contains at least one tail, means one or more than one tail. So here no tail, here one tail, here one tail, here two tails. So this is event of getting at least one tail. So here number of outcomes is 3. So we want the probability of this event. Therefore, required probability is, that is probability of A is 3 by 4. That is probability of required event. Now see here, this is a question of cards. Whenever we solve a question of card, then remember types of cards. There are 52 cards. If you are playing cards, then you can know about types of cards. Otherwise, keep remember this point. In a bunch, there are 52 playing cards. In these 52 cards, there are 4 types. 13 spades. 13 cards are of spades. 13. Let I need here a space to solve this question. So getting more space. Whenever you solve any problem of cards, keep remember this values. There are 53 cards. In these 53 cards, there are 4 types. 13 cards are of spades. 13 cards are diamonds. 13 cards clubs, and 13 cards heart. Let me change this order. Here I am putting club and here heart. See, these are spades and clubs. These are of black cards. And these are of color red cards. 26 red, 26 black cards. Now, face cards. In this 53 cards, say in this 53 cards, there are 12 face cards, and I am putting here 12 face cards, and remaining that is 40 other cards, non-face cards. Now in these face cards, these 12 face cards, there are 4 king, 4 queens, and 4 jacks. This is information about face cards. So this is about playing cards. Now we solve this question. A card is selected from a pack of 52 cards. How many points are there in the sample space? Sample space, that is set of all possible outcomes. So here a experiment is a card is selected from a pack of 52 cards. So when a card is selected from a pack of 52 cards, then which are possible outcomes? When you select any card from 52 cards, bunch of 52 cards, any card can be selected. So there are total 52 possible outcomes. So here sample space contains 52 sample points. That is answer of first question. So number of ways of selecting a card, number of ways of selecting a card from a pack of 52 cards is 52C1. So 52C1, that is 52. Therefore, this is total number of outcomes. So number of sample points in the sample space is n equal to 52. In this experiment, if you are asked to select 2 cards, then number of ways of selecting 2 cards from a pack of 52 cards. So total number of such selections 52C2. So in that case, here you have to find value of 52C2, that is 52 into 51 upon 2 into 1. Then second question, second answer. Calculate probability that card is an ace of spades. Card, we are asked probability of this event, that selected card is an ace of spade. An ace of spade. Now see, there are four aces. There are 4 aces in bunch of cards. And these 4 ace cards, one is of spade, one is club, one is diamond, each one of different type. Here 4 ace cards, one ace card is of spade, one of diamond, one is club, one is heart. Ace of spade, ace of diamond, ace of club, ace of heart. Now we want probability that card is an ace of spade. So ace of a spade, there is such only one card. So number of selecting a card, which card? An ace of spade. So number of selecting an ace card of spade, that is R equal to, in a bunch of 52 cards there is only one card which is an ace card of spade. So such selection contains only one card. So probability of this event, therefore probability that or probability of this event is 1 upon 52 R upon N. Then C, calculate probability that the card is an S or black cards. See, probability that, now there are 4 S cards. So in C, first question, S cards 4, and black cards. There are black cards 13 plus 13, 26. Now here required probabilities. Probability that card is an S card. There are 4 S cards. So related event contains 4 elements. Sample space contains 52 elements. So required probability is 4 by 52. 4 by 52, that is 1 by 13. What is the probability that selected card is of a black card? If selected card is of a black card, then it comes from this 26. So related event contains 26 cards. So required probability is 26 upon 52, that is 1 by 2. So whenever we solve any question of cards, then keep remember this note. A fair coin with 1 marked on one face and 6 on the other face, and a fair die are both tossed. Find the probability that the sum of numbers that turns up is 3 and is 12. Say a coin. On coin, generally on both the sides there are 2 outcomes, either H or T. But here instead of H and T, the numbers are marked 1 and 6. So one side 1, other side 6. And we know that on a die there are 6 faces, 6 digits, 1 to 6. Now both are tossed. So sample space associated with this experiment is, first outcome I will put from a fair coin and second output will be from a die. Suppose on a fair coin, suppose 1 appears, then with 1 on a fair die, it can be 1, it can be 2, 1 I am keeping constant. This is outcome from a die. Sorry, first number is outcome from a fair coin and second is from a fair die. So 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Now on a fair die, if suppose 6 appears, that is other side appears on which 6 is marked, then with that on a fair die 1 can appear with 6, 2 can appear with 6, 3 can appear with 6, 4 can appear, 5 and 6. So this is set of possible outcomes. So this set contains 12 outcomes. So here n is 12, 6 plus 6, that is there are 12 outcomes. Now we need probability that sum of numbers that turns is 3. So let me denote A be the event that sum of numbers is 3. So event A contains now sum of numbers 3. So this element contains sum of numbers 1 plus 1 2. So it is not 3. Here 1 2, it contains sum of numbers 3. So 1 2 is included in this event. Now there is no any other element in which sum of numbers is 3. So this is only the element in which sum of numbers is 3. So here this event contains one element. So here R is 1. Number of outcomes in event. So probability of A is 1 upon 12. Then if sum of numbers is 12, let me denote that event as B. B is the event that sum of numbers is 12. Now check elements. This is only the element in which sum of numbers is 12. So B contains only one element, 6, 6. So here this set contains also only one element. So probability of B is 1 by 12, R upon N. So in both the cases probability is 1 by 12. Now here there are 4 men and 6 women. 4 men, 6 women. So total there are 12 persons. Total 12 persons. Now experiment is, one council member is selected from a committee, for a committee. So if any one is selected from this 12, then total number of selection of one council member is from 12 select any one. So 12C1. If you want 2 council members, take 12C2. If you want 3 council members, take 12C3. So here only one is required, one is asked, so 12C1. So this is number of sample points in sample space. So N is 12. Now, how likely is it that it is a woman? So what is the probability that selected council member is a woman? So let me say now, number of ways of selecting a women council member. So we are now on particular event is, we are asked a probability of this event. What is the probability that woman council member is selected? So this event contains number of elements. See, there are 6 women. So number of ways of selecting a woman council member is 6C1. So it is 6. This is R. So required probability is R upon N, that is 6 by 12. So that is 1 by 2.